discuss a topic vector. So it is a topic in mathematical tools, 11th class physics. So vector definition wise, any physical quantity which has magnitude, direction, and also follow the rules of vector addition particularly is a vector quantity. Now, how to represent a vector? So vector is represented by an arrow. It has tail and head. There is arrow on the head and this is tail. So it has tail and head. Direction is from tail to head. So length of the arrow is proportional to its magnitude and direction is from tail to head. And length of the vector is proportional to magnitude. More is the length, more is the magnitude of vector. Now we will discuss few basic types of vector. So first one is position vector or fixed vector and free vector. So position vector we are trying to discuss first. Position vector, this is an example of fixed vector. Suppose we have a coordinate system. Now to represent the position of any point on the coordinate system, let this is a point, let this point is A. This is the origin of coordinate system. So this point A is located at this location. So if I join origin with point A, then this vector OA, where O is tail, A is head, direction is from O to A, this is called position vector of point A. This is called position vector of point A. Similarly, if we take some other point, let it be B. If I join origin with B, then this vector OB, this is nothing but position vector of point B. This is position vector of point B. So position vector is a fixed vector because its tail is always at the origin. So from that point of view, it is a fixed vector. So this is all about position vector. Then next type of vector is called displacement vector. These are all vectors we will particularly use in physics. So we are discussing vector from physics point of view so that we can apply all the points that we learn here about vector. We have to apply all these points in kinematics, particularly in physics. So displacement vector. So if we talk about displacement vector, then as we just discussed that about position vector, suppose we have 2 point A and B, position vector of point A is vector OA and position vector of point B is vector OB. Now if I join point A with point B, then vector OA plus vector AB, that is equal to vector OB. So displacement, this is position vector of A plus position vector, displacement vector AB, then position vector of point B. So from here we can write vector AB, which is a displacement vector AB, because if we talk about vector AB, so tail is A and head is B, so this is displacement vector AB. This is displacement vector AB. So displacement vector AB is nothing but position vector of B minus, this will go to other side, position vector of A. So this is a very obvious result that any displacement vector is nothing but position vector of final point minus position vector of initial point. Here in displacement vector AB, A is the initial point, that is tail, B is the final point, that is head. So displacement vector AB is nothing, final position vector minus initial position vector. A is initial, B is final. Suppose a person is moving from A to B, then for him displacement is AB. And displacement, we also know that it is the shortest distance between 2 points. That should also we keep in mind. Displacement is shortest distance between 2 points. So displacement vector, displacement between 2 points is nothing but shortest distance between those 2 points. That is all about displacement vector, right? So this OA plus AB is equal to OB. This we can also say this is triangle law. So triangle law we can separately discuss in this way also. Now triangle law, I am discussing triangle law. Triangle law means, suppose this is a vector AB and this vector BC. So if I say vector AB means if somebody is going from A to B, then he is going from B to C. Instead of doing this, he can directly move from A to C. So this is equal to vector AC. Means, as per triangle law, if two vectors are represented by two adjacent sides of a triangle taken in order, then their resultant is given by third side in reverse order. See, if we start from point A, we are going from A to B, then in continuation we are going from B to C. Now we have to lift the pen and again put it on the O. So this is in reverse order from A to C. So vector AB plus vector BC is equal to vector AC. Means, statement wise we can say that if two vectors can be represented or is represented by two adjacent sides of a triangle in order, then their vector sum is given by third side in reverse order. Okay, you can write this also. If two vectors are represented by two sides or two adjacent sides of a triangle in order, then their vector sum is given by third side of the same triangle in reverse order. So this is triangle law. This is triangle law in vector. Now we will move to next topic. So we have discussed two types of vector, that is position vector and displacement vector, and also about triangle law. Right? Now as I told you, there are two types of vector, fixed vector and free vectors. Example of fixed vector is You can consider position vector. Position vector is an example of fixed vector because its tail is always at the origin of the coordinate system. Free vectors, we can have example velocity, acceleration. These are all example of free vector. Velocity and acceleration are example of free vector. Then one more type of vector we can write for simplicity or for convenience, that is polar vector. Polar vector means which has got a point of application. For example, force. Force is an example of polar vector. Free vectors means those vectors which can be translated parallel to itself. This is an important line that we should learn about free vectors. Free vectors means those vectors, free vectors are those vectors which can be translated parallel to itself. Free vectors can be translated parallel to itself. So if we translate a vector parallel to itself and it makes no difference, it means it is free vector. But we need not to go into so much detail because the mathematics of fixed vector and free vectors, they are same, so it makes no difference to us. So we will simply put free vectors in our mind. Position vector is just to represent any position of any particular particle on the coordinate system. So that is why also position vector is not considered as true vector, but anyway that is all into details. We need not to go into all those details. They are just irrelevant to us. So these are just basic definition we should keep in mind. Then some more other vectors which are more useful to us, that is unit vector. Unit vector, as the name suggests, it is a vector whose magnitude is one unit. Unit vector is a vector whose magnitude is 1 unit. Or if we divide any vector by its magnitude, suppose we have a vector AB, this is the tail of vector A, this is head of vector, this is tail of vector, this is head of vector. So this vector is vector AB. So if we divide this vector by its magnitude, means this is vector AB, and if we divide the vector by its magnitude, this is the simple mod represent magnitude of vector means length of the vector. So if we divide any vector by its magnitude, we get a unit vector along the direction of the vector AB. So this is a unit vector directed along the vector AB, directed along vector AB. So to represent a unit vector, many times we use a symbol, that is cap. This cap is representation of unit vector. So this is how we represent unit vector. We can also write it this way also. Okay. There may be some other way of representation also, but right now we are more concerned about the definitions. So this is all about unit vector. Means unit vector is a vector whose magnitude is 1 unit, and if we divide any vector by its magnitude, okay, then now we can write in so many ways. See, If we consider this vector AB, now if I join origin to A and origin to B, so as I told you that vector AB can also be written like vector OB minus vector OA. Vector AB, that is displacement vector AB, that is equal to position vector of B minus position vector of A, divide by magnitude. So we can write this way also. The same thing we are writing. AB, we write whether AB or OB minus OA, it is same thing. Even if I give some other symbol, suppose I term vector OA as R1, that is initial position vector, and vector OB as R2, that is final position vector. So we can write it like this also, R2 minus R1. So AB we can write it like this. So mod of AB we can write like this also, R2 minus R1, and as this is mod, like this. So these are all same thing. They may appear different, but these are same thing. Whether we write it like this, whether we write it like this, or whether we write it like this, it is not a matter of worry. All mean same thing. Vector OA, that is initial position vector, particle initially was at location A and finally it was at location B. So we term it as initial position vector also. One for initial and two for final. Generally we use this term, initial position vector and final position vector. And R2 minus R1, we can also write R2, that is final position vector minus initial position vector, upon mod of the vector AB. We can also write this vector like del R. Del R means difference in position vectors. So R2 is final position vector, R1 is initial position vector, that we can write del R also, and that is R2 minus R1 and mod. This is unit vector along the position vector. So this is also way of representation. So there may be different way of representation. That is not a matter of worry. We will learn it over time, right? So this much is all about unit vector. Then negative vector. Negative vector means, it simply means if we multiply a vector with negative sign, its direction changes. Suppose this is a vector AB. Vector AB means is a vector which is directed from A to B. Now if I multiply vector AB with minus sign, then it simply becomes vector BA. It simply means when we multiply a vector with negative sign, its direction reverse. AB becomes BA. So if we multiply vector AB with negative sign, it becomes vector BA. It simply means when we multiply any vector with negative sign, its direction reverse. Tail become head and head become tail. So this is all about negative vector. This is all about negative vector. So these two are of prime importance in physics. So right now we will discuss only about unit vector and negative vector. So now we will move for vector addition. Vector addition. How to add two vectors. How to add two or more than two vectors. So for adding two or more than two vectors, we can use triangle law. Suppose I have two vectors. One vector is, let it be vector AB, and another vector is vector BC. And now suppose we have to add these two vectors. So while adding, we will consider the vector as free vectors. So take any point as origin, draw a vector parallel to AB and fix the tail. This is vector AB. Now this is vector BC. So translate this vector BC parallel to it. So this vector becomes vector BC. So if I am asked to find summation of these two vectors, that is AB plus BC, then I have to do nothing. I have to join the tail of the initial vector to the head of the final vector. So this is the vector AC. So this, if I add these two vectors, I will get this one. So this is again by using triangle law of vector we can use it. So triangle law of vector statement we have already discussed. That is, if we represent two sides of triangle by two vectors, or if we represent two vectors by two adjacent sides of a triangle, then their vector sum is given by a third side in reverse order. So this is how we can add two vectors. Okay, we may be required to add more than two vectors. Then in spite of triangle law, we have to use polygon law. Okay, suppose I have a vector this AB, then a vector BC, then vector CD. Now I have to add these three vectors AB plus BC plus CD. So I have to do nothing. I have to simply join the initial point tail of the initial vector to head of the final vector. That is this. So my answer will be vector AD. So this is called polygon law. Okay. So here we are adding three vectors AB plus BC plus CD. AB plus BC plus CD. So their vector sum will be vector AD. Sorry, vector AD. This is D. This is D. Okay. So let me correct it. So this is vector AD. Oh, sorry. Again I have written B. Similarly, we can add more than three vector also. So this is called polygon law of vector, which is nothing but extension of triangle law of vector. Most of the times we will end up using triangle law. We hardly need application of polygon law. This is more applicable in physics. Now, if we represent a vector into rectangular components, means orthogonal components, that is, suppose we have a coordinate system x and y. So this is an orthogonal coordinate system, x, y axis both are perpendicular to each other. Now suppose I have a vector A. It can be anything. Suppose I write vector OA, simply represented by small letter a, and suppose this vector is nothing but 3i plus 4j. So this I, j and k, I cap, this is unit vector, means I is a vector whose magnitude is 1 unit. So I cap is a unit vector parallel to x-axis, parallel to x-axis. Similarly, j is a unit vector along y-axis, unit vector along y-axis, and k cap is unit vector along z-axis. Now I am considering a vector OA that is represented by small. So this is suppose origin. So vector OA means 3i plus 4j. Vector OA, I am simply writing it by single letter small a. That is, I have given as 3i plus 4j. So what I have to do? I have to start from origin. I have to move 3 unit along positive x-axis. So 1, 2, 3. Then I have to move 4 unit along parallel to y-axis. So 1, 2, 3, 4. Finally, I have reached here. So I will do nothing. I will simply join the initial point to final point. This vector is vector A. This vector is vector A. Right? And this 3i and 4j, they are components of vector A. They are components of vector A. They are components of vector A. So these are also called rectangular components. Why? Because these components are perpendicular to each other. They are also called rectangular components because they are perpendicular to each other. Now if I generalize in that case, suppose I write a vector A like this, xi plus yj, it simply means I have to move x unit along x axis, then y unit along y axis, finally reached here. So now my vector is xi cap plus y j cap. So these two are perpendicular to each other. They are also called rectangular component of vector A. This vector xi and this vector yj, xi means its magnitude is x, and when we multiply it by I cap, it becomes a vector whose direction is along positive x. If we multiply any vector, if I multiply any quantity with a unit vector, in that case direction of that quantity becomes parallel to the direction of unit vector, right? So these are perpendicular to each other, xi and yj, so they are also called rectangular components of vector A. So xi plus yj are xi and yj. Xi means x into I cap. Xi and yj are rectangular components of vector A. They are rectangular components of vector A. So we can add any two vectors simply by translating parallel to them. Okay, whether they are fixed vector or they are represented on a coordinate system, it makes no difference to us. Now we can represent any vector into its rectangular components also. Generally in rectangular component, when we talk in a plane, we have two axes, x axis and y axis, and when we are talking in space, we have three component, x axis, y axis and z axis. All are perpendicular to each other. So in plane generally we resolve a vector into two components, and in space we resolve a vector into three components. Means in plane generally we split a vector into two components which are perpendicular to each other, then they are called rectangular components, and in space we resolve a vector generally into three components which are perpendicular to each other, okay, x, y and z. So they are called rectangular components. Means if we split a vector into components, and if the components are perpendicular to each other, they are called rectangular components. They are called rectangular components. Now let us discuss resolution of vector. Let us discuss resolution of vector. Means that is how to resolve a vector into two or more than two components. So first we will discuss how to resolve a vector into two components. So here we can remember, suppose we have a vector r directed along this direction. So if we split this vector into two components,